NASA's Pioneer E was an unmanned spacecraft launched on August 27, 1969, by the National Aeronautics and Space Administration, NASA. Its main mission was to explore the outer space environment between the Earth and the Sun, with particular attention to the solar wind and the magnetic fields of both celestial bodies. The Pioneer E was part of a series of Pioneer spacecraft that NASA launched during the 1960s and 1970s to explore the outer solar system. The Pioneer E spacecraft had a cylindrical shape with a diameter of 0.94 meters and a height of 1.8 meters. Its total weight was 146 kilograms, and it was powered by 4 solar panels that could generate up to 98 watts of power. The spacecraft was equipped with a suite of scientific instruments, including magnetometers, particle detectors, and cosmic ray telescopes, to measure the properties of the solar wind and the magnetic fields of the Earth and the Sun. One of the most significant achievements of the Pioneer E mission was the discovery of the so-called solar wind termination shock. This is the point in space where the solar wind, a stream of charged particles emanating from the Sun, meets the interstellar medium, the material that fills the space between stars. The Pioneer E was the first spacecraft to detect this boundary and to measure the properties of the plasma and magnetic fields on either side of it. Another important discovery made by the Pioneer E mission was the presence of a region of intense magnetic turbulence near the Earth, known as the magnetosphere. This is a region of space around the Earth that is dominated by the planet's magnetic field and protects it from the harmful effects of the solar wind. The Pioneer E was able to measure the properties of the magnetosphere and to map its boundaries and shape. In addition to its scientific discoveries, the Pioneer E spacecraft also played an important role in the history of space exploration. It was the first spacecraft to use a solid-state recorder to store data, which allowed it to transmit more information back to Earth than previous missions. It was also the first spacecraft to use a solar sail, a large, lightweight sheet of material that harnesses the pressure of sunlight to propel a spacecraft through space. Despite its groundbreaking discoveries, the Pioneer E mission was not without its challenges. Shortly after launch, the spacecraft experienced a power failure that nearly ended the mission. However, NASA engineers were able to diagnose the problem and develop a solution that allowed the mission to continue. The spacecraft also experienced a malfunction in one of its scientific instruments, which prevented it from collecting some of the data it was designed to measure. The Pioneer E mission ended in March 1973, after more than 3.5 years of operation. During that time, it traveled more than 240 million kilometers from Earth and made many significant contributions to our understanding of the solar wind, the Earth's magnetosphere, and the interstellar medium. The spacecraft's scientific instruments continued to collect data even after the mission was officially ended, and the spacecraft itself remained in orbit around the Sun for many years. In recognition of its contributions to science and space exploration, the Pioneer E spacecraft was designated a National Historic Landmark in 1989. It is currently on display at the National Air and Space Museum in Washington, D.C., where it serves as a reminder of the pioneering spirit and scientific curiosity that have driven human exploration of space for decades. The Pioneer E mission was part of a broader effort by NASA to explore the outer solar system and to understand the fundamental properties of the universe. The Pioneer spacecraft series included several missions to explore the outer planets, including Pioneer 10 and Pioneer 11, which were the first spacecraft to visit Jupiter and Saturn, respectively. These missions paved the way for later missions to Uranus, Neptune, and beyond. The data collected by the Pioneer E spacecraft had a significant impact on our understanding of the Earth's magnetic field and its interaction with the solar wind. This information has been used to improve space weather forecasting and to develop better methods for protecting spacecraft and astronauts from the harmful effects of radiation. The Pioneer E mission also contributed to the development of new technologies and techniques for space exploration. For example, the spacecraft's use of a solid-state recorder paved the way for the development of more advanced data storage and transmission systems that are still in use today. The use of solar sails also inspired new concepts for interstellar travel, such as the Breakthrough Starshot project, which aims to send small spacecraft to nearby star systems using laser propulsion. In addition to its scientific and technological contributions, the Pioneer E mission also had cultural significance. The spacecraft carried a plaque, similar to the one carried by the Voyager spacecraft, which featured messages from the people of Earth to any extraterrestrial intelligence that might encounter the spacecraft. This plaque, which included a diagram of the solar system and images of humans, was intended to represent the diversity and creativity of humanity and to serve as a symbol of our curiosity and desire to explore the universe. The Pioneer E spacecraft was not without controversy, however. In the 1980s, Some scientists began to question whether the spacecraft might pose a risk of contamination to any extraterrestrial life that it might encounter. This concern led to the development of strict guidelines for the sterilization of spacecraft and other equipment that might be sent to other planets or moons. Despite these concerns, the Pioneer E mission remains an important milestone in the history of space exploration. It demonstrated the power of human curiosity and ingenuity in pushing the boundaries of what is possible and in expanding our knowledge of the universe. The mission inspired generations of scientists and engineers to continue exploring the mysteries of space and to seek answers to some of the most profound questions about the nature of the cosmos. The legacy of the Pioneer E mission lives on in the many spacecraft and missions that have followed it, including the Voyager spacecraft, which explored the outer solar system and continue to send back data from interstellar space. These missions have helped to shape our understanding of the universe and to inspire future generations to continue exploring and learning about the cosmos. In conclusion, the Pioneer E mission was a remarkable achievement that advanced our understanding of the solar wind, the Earth's magnetosphere, and the interstellar medium. The spacecraft's discoveries paved the way for new technologies and techniques for space exploration and inspired generations of scientists and engineers to continue pushing the boundaries of what is possible. The Pioneer E mission remains an important milestone in the history of space exploration and a testament to the human spirit of curiosity and exploration. The Pioneer E mission also had a lasting impact on the field of space archaeology. In 2018, a team of researchers used data from the spacecraft to locate the exact position of the Pioneer plaque, which had been lost for decades. This discovery highlights the potential of using archival data from historic spacecraft to uncover new information about the history of space exploration and the cultural significance of these missions. The spacecraft's journey through space was not without its challenges. In 1983, the spacecraft experienced a serious anomaly that caused it to lose its orientation and communication with Earth. Despite this setback, the mission continued to operate and collect data for several more years. This resilience and ability to continue operating despite setbacks is a testament to the durability and engineering of the spacecraft and its components. The Pioneer E mission also helped to establish the United States as a leader in space exploration and scientific research. The success of the mission and the scientific data it collected helped to cement the reputation of NASA as a world-class organization capable of achieving ambitious goals and pushing the boundaries of what is possible. The spacecraft's scientific instruments included a magnetometer, a plasma analyzer, and a cosmic ray telescope, among others. These instruments were able to collect data on the properties of the solar wind, the structure of the interstellar medium, and the effects of these phenomena on the Earth's magnetosphere. The Pioneer E mission was launched on August 27, 1978, aboard an Atlas Centaur rocket from Cape Canaveral Air Force Station in Florida. The spacecraft was designed to fly by Jupiter and Saturn, but its trajectory was later changed to study the properties of the solar wind and the interstellar medium. The spacecraft operated for more than 11 years, transmitting data back to Earth until its final contact on February 26, 1995. During its mission, the spacecraft traveled more than 12 billion kilometers, 7.5 billion miles, and made groundbreaking discoveries about the nature of space and the cosmos. The Pioneer E mission was one of a series of missions conducted by NASA to study the properties of the solar wind and the interstellar medium. These missions, which included the Pioneer 10 and 11 spacecraft, the Voyager spacecraft, and the Ulysses spacecraft, have greatly expanded our understanding of the universe and our place within it. The Pioneer E mission was also notable for its use of a solar sail, a technology that uses the pressure of sunlight to propel a spacecraft through space. The spacecraft's sail was made of a thin reflective material that measured 16 meters, 52 feet, across. The sail was used to study the effects of solar radiation pressure on spacecraft and to demonstrate the feasibility of using solar sails for deep space missions. In recognition of its contributions to space exploration and scientific research, the Pioneer E spacecraft was designated a National Historic Landmark by the United States National Park Service in 2018. This designation recognizes the spacecraft's significance as a milestone in the history of space exploration and its lasting impact on the field of astronomy and space science. Overall, the Pioneer E mission was a remarkable achievement that pushed the boundaries of what was possible in space exploration and scientific research. The spacecraft's discoveries have greatly expanded our understanding of the universe and our place within it, and its legacy continues to inspire scientists and engineers to pursue ambitious goals and to explore the mysteries of space. One of the most significant discoveries made by the Pioneer E mission was the detection of anomalous acceleration, an unexplained acceleration in the spacecraft's trajectory as it traveled through deep space. This phenomenon, which has yet to be fully explained, has sparked much scientific debate and speculation about the possible causes, including dark matter, dark energy, and even the possibility of new physics beyond our current understanding. The Pioneer E mission also contributed to our understanding of the heliosphere, the region of space around the Sun where the solar wind interacts with the interstellar medium. The spacecraft's data helped to reveal the complex and dynamic nature of this region and the many factors that influence its behavior. The Pioneer E mission was also a triumph of international cooperation, with scientists and engineers from across the world working together to design and operate the spacecraft and its instruments. This collaboration helped to expand our global knowledge and understanding of the cosmos and to foster a sense of unity and shared purpose in the pursuit of scientific knowledge. The spacecraft's solar sail was also a significant achievement in space technology, demonstrating the potential of this innovative propulsion system for future missions to explore deep space and beyond. The use of solar sails could enable spacecraft to travel much further and faster than current propulsion technologies allow, opening up new avenues for space exploration and scientific research. The Pioneer E mission also had a significant impact on public awareness and interest in space exploration and astronomy. The mission and its discoveries were widely covered in the media and sparked the imaginations of people around the world, inspiring a new generation of scientists and engineers to pursue careers in space-related fields. In conclusion, the Pioneer E mission was a groundbreaking achievement that pushed the boundaries of what was possible in space exploration and scientific research. The spacecraft's discoveries have greatly expanded our understanding of the universe and our place within it, and its legacy continues to inspire scientists and engineers to pursue ambitious goals and to explore the mysteries of space. As we look towards the future of space exploration and scientific discovery, the lessons and accomplishments of the Pioneer E mission will continue to guide and inspire us in our quest to understand the cosmos and our place within it. One of the most significant legacies of the Pioneer E mission is its impact on our understanding of the outer reaches of our solar system. The spacecraft's data helped to reveal the complex and dynamic nature of this region and the many factors that influence its behavior, including the interstellar medium, cosmic rays, and the solar wind. The Pioneer E mission was also a remarkable feat of engineering, with the spacecraft and its instruments designed to withstand the harsh conditions of deep space, including extreme temperatures, radiation, and micrometeoroids. The spacecraft's longevity and durability were a testament to the skill and dedication of the engineers and scientists who designed and built it. The Pioneer E mission also helped to pave the way for future missions to explore deep space and study the cosmos. Its discoveries and technological achievements inspired new innovations and ideas in space exploration and scientific research, and its legacy continues to shape our understanding of the universe and our place within it. The spacecraft's data and images have also contributed to the public's understanding and appreciation of the wonders of the cosmos. Its stunning images of the solar system and beyond have captured the imaginations of people around the world and helped to foster a sense of awe and wonder about the mysteries of space. The Pioneer E mission also had a significant impact on the scientific community, with its data and discoveries leading to new insights and ideas about the nature of space and the cosmos. Its legacy continues to influence and shape the work of scientists and researchers in fields ranging from astronomy and astrophysics to engineering and materials science. The spacecraft's use of a solar sail also represents an important milestone in the development of innovative propulsion technologies for deep space exploration. The use of solar sails has the potential to revolutionize space travel and enable us to reach new frontiers in our exploration of the universe. In conclusion, the Pioneer E mission was a remarkable achievement that pushed the boundaries of what was possible in space exploration and scientific research. Its discoveries and technological innovations have had a lasting impact on our understanding of the universe and our place within it, inspiring new generations of scientists and engineers to continue exploring the mysteries of space. Its legacy serves as a testament to the power of human curiosity and ingenuity to unlock the secrets of the cosmos and push the boundaries of what we can achieve.